Hello! In this video, we are going to evaluate the following integral. The integral of secant cubed of x dx. So we're evaluating an integral of the form secant to an odd power. Now, when evaluating integrals like this, like for instance, integral of secant cubed, integral of secant to the fifth, integral of secant to the seventh, or integral of secant to the ninth, what we can do is we can use integration by parts. And the way we're going to use integration by parts is we're first going to isolate a secant squared. And the way we can do that is we can rewrite secant cubed of x as secant of x times secant squared of x. And now we're going to use integration by parts. So the formula we need is the integral of u dv is equal to uv minus the integral of v du. Now, in this case, we're going to take secant of x to be u, and secant squared of x dx to be dv. And we would like to figure out du and v. Now, du is just the derivative of secant x, which is just secant x tangent x. And let's not forget the dx. And v is just the antiderivative of secant squared x, which we know is tangent x. Okay, so now that we know all four pieces of information, let's apply this formula. Right now, our integral is in the form integral of u dv. And by this formula, it's equal to uv minus integral of v du. Now, uv in our case is secant x times tangent x. And we're subtracting this by the integral of v du, which in our case, that is the integral of tangent x times secant x tangent x dx. Or in other words, that's just the integral of secant x tangent squared x dx. Now let's use the trig identity for tangent squared x. Tangent squared x is just secant squared x minus 1. And then, distributing secant x across the parentheses, we get this. But then, let's split this integral up into two integrals, right? We're going to be distributing the minus sign across, and if we do that, well, we're going to get minus the integral of secant cubed x dx. And then, these two negatives join forces to make a positive, and we get plus integral of secant x dx. Now at this point, it may not be super clear where this is going, because we started off with this as our original integral, and we ended up with our original integral again. So what do? Well, overall, we have showed that our original integral is equal to what we have here. But what we can do is we can use algebra, right? That was good. And we can add the integral of secant cubed x dx to the other side of the equation. If we do that, we see that this goes away, and what we're left with on the left side of the equation is 2 times the integral of secant cubed x dx. And this is just equal to secant x tangent x plus the integral of secant x dx. And then let's just divide 2 to the other side. And then, if you recall, the integral of secant x dx is just natural log of absolute value of secant x plus tangent x. And at this point, let's add our constant of integration plus c. So this is our final answer. So the integral of secant cubed of x is this. And so yeah, that's pretty much it for this video.